Namaskar and welcome back to Aviation Avi. Go where you feel the most alive. In part 2 of the video on physical characteristics, we'll talk about the runway, the shoulder, the turnpad, and other physical characteristics like the slope and the strength of these surfaces. So, without any delay, let's get started. Like we discussed in the part 1 of the video, physical characteristics defines the characteristics required for runways, taxiways, aprons, strip, shoulder, RESA, clearways, and stopways. The specific number citing orientation of the runways, including the requirement for a usability factor of 95% for aircraft types the aerodrome is meant to serve. It also talks about the standards for runways, taxiways, apron, dimension, that is the length, width, and for threshold location, displaced threshold when required. The limits for slopes, that is the longitudinal slope, the transverse slope, and the changes in the slope are safer under various weather conditions. So this is what Chapter 3 of ICAO Annex 14 physical characteristics talks about. Like you see this aerodrome, this is the runway, this is the apron, and these are the taxiways connecting the runway to the apron. So they have defined physical characteristics they must have. They have defined length, defined width, defined slope, defined dimensions of strip associated, shoulders associated. So this chapter gives you the specification of these critical facilities that the aerodrome provides. Number 1. Strength of runways. The runway shall be capable to withstand the traffic of aeroplane the runway is intended to serve. So the strength of the runway should be enough in order to ensure safe operation of the aircraft that the runway is primarily intended to serve. The surface of the runway shall be constructed without irregularities that would impair the runway friction characteristics or otherwise adversely affect the takeoff or landing of the aircraft. Now, the surface of the runway should be built without irregularities because irregularity can adversely impact not only the friction characteristics but could also impact the takeoff or landing of the aircraft. When it comes to friction characteristics, while building the runway, the friction characteristic is supposed to be at design objective for new surface levels. So these are defined friction levels by DGCA. Whenever the friction level goes below the defined levels, now we will look at these levels slowly. Necessary mitigation action is to be put in place. That is, you must carry out necessary maintenance activities of the runway, or if it has deteriorated below a level that friction characteristics it cannot be restored by normal maintenance, you have to carry out resurfacing of the entire runway surface. Now, after you have constructed the runway, there is takeoff and landing taking place on the runway, and with every landing there is rubber deposit on the runway. So slowly and slowly, with the wear and tear of the runway increasing rubber deposit, the friction characteristics goes below the design objective of new surface and it comes down to MPL. MPL is maintenance planning level. As the name suggests, you must initiate maintenance when the friction characteristics goes below MPL. Further, with further wear and tear and rubber deposit, the friction characteristic can come down to MFL, that is minimum friction level, which says that the friction is too low to carry out safe operations. So, with this, it says that the runway may be extremely unsafe, especially when the runway is wet. So, there is necessary mitigation to be put in place when the friction characteristic goes below MPL and MFL. Now, we have made a detailed video on runway friction characteristics. I'll provide the link of this video in the description. Further, when the runway friction is not achieved in a particular area and is creating a problem in flight operations, the surface may be grooved or scored. The grooves or scorings shall be perpendicular to the runway centerline or parallel to the non-perpendicular transverse joints where applicable. Like you see groovings, there are extra cuttings made on the runway in order to increase the friction characteristics. So in order to ensure safety of aircraft operations, you can provide grooves or scoring on the runway. In our previous video, we saw that with the outer main gear wheel span of the aircraft that the runway is intended to serve, as this criteria increases, the width of the runway required also increases. But the maximum width of the runway is limited to 45 meters for an aircraft with the outer main gear wheel span of 9 meters up to, but not including 15 meters. Now, in order to aid with the safety of aircraft operations as the dimension of the aircraft increases. As the outer main gear wheel span increases, the runway is supplemented with runway shoulders, as you can see here. And these runway shoulders help. Now, runway shoulders shall be provided for a runway where the code letter is D, E, or F. We know that D, E, or F is pertaining to the wingspan of the aircraft the runway is intended to serve. Further, the aeroplanes with outer main gear wheel span from 9 meter up to but not including 15 meter, the runway shoulders shall extend symmetrically on each side of the runway so that the overall width of the runway along with the shoulders is not less than 60 meters where the code letter is D or E. In case the runway is intended to serve an aircraft with the code letter D or E, the total width of the runway from shoulder to shoulder should be 60 meters. We know that the width of the runway for aeroplanes with outer main gear wheel span of 9 meter up to but not including 15 meter and for a code 4 runway is 45 meters. So shoulder plus the width of the runway, total width of the runway becomes 60 meter. That means on each side you provide a runway shoulder of 7.5 meters. So 45 plus 7.5 plus 7.5 is 60 meters. Further, when the runway is intended to serve a code letter F aircraft with 2 or 3 engines, in that case also the total width of the runway along with the shoulders should not be less than 60 meter. Now, in case it is intending to serve a code F aircraft with 4 or more engines, in that case the total width of the runway along with the shoulder should be 75 meters, which means on each side you provide a shoulder of 15 meters. Now, the surface of the shoulders that abuts the runway shall be flush with the surface of the runway. You understand this? The surface of the shoulder that abuts the runway, that is close to the runway, it should be leveled, it should be flush, and the slope shall not exceed 2.5%. This, this slope especially helps to drain out water from the runway. Now, the portion of the runway shoulder between the edge and a distance of 30 meters from the runway centerline shall be prepared or constructed so as to be capable, in the event of an aircraft running off the runway, of supporting the aeroplane without including structural damage to the aeroplane and supporting ground vehicles which operate on the runway. What this means is that we know that for a code 4 runway, aircrafts operating on it having an outer main gear wheel span of 9 meters up to but not including 15 meters, the width of the runway is 45 meters. So the length extending on each side of the center line is 45 by 2, that is 22.5 meters. And what this says is the portion of the runway shoulders between the runway edge and the distance of 30 meters. So up to here is your 22.5 meters and the whole shoulder is 30 meters. That means this additional length of 7.5 meters, it should be constructed in a way that it is able to bear the weight of the aircraft when the aircraft is running off the runway, and it can also safely bear the weight of the ground vehicles that is operating on the shoulder. Now that we have seen the runway and the shoulders, let us look at turn-pads. Now, what are turn-pads? As the name suggests, it allows the aircraft to make a 180-degree turn on the runway. Now, when the runway is not served by a taxiway or a taxiway turnaround, in that case, you provide a turn pad. It is a mandatory requirement in such cases to provide a turn pad for code letters D, E, or F, and it is a recommendation. And it is a recommendation that turn pad is provided for aircrafts of code A, B, or C. The intersection angle of the turn pad with the runway shall not exceed 30 degrees. You see here the intersection angle of the turn pad with the center line. This angle, you see here, it should not exceed 30 degrees. The nose wheel steering angle to be used in the design of the runway turn pad shall not exceed 45 degrees. Basically, when you are designing this turn pad, the nose wheel steering angle should also not exceed 45 degrees. Now let us look at the design of a runway turn pad. It shall be such that when the cockpit of the aeroplane for which the turn pad is intended remains over the turn pad marking. So when you are designing a turn pad for this particular aircraft, and when this is maneuvering and it is making a 180-degree turn on the turn pad, The clearance distance between the wheel of the aeroplane landing gear and the edge of the turnpad shall be not less than the following. That means that these aircrafts have the main landing gear. The distance between the outer main landing gear and the edge of the pavement shall not be less than the value that is mentioned in this table. Particularly, let us look at an aircraft having a outer main gear wheel span of 9 meters up to but not including 15 meters. That means, in this case, the distance between the outer main gear wheel and the pavement shall not be less than 4 meters. Now, further, if we look at the clearance for an outer main gear wheel span of 6 meters up to but not including 9 meters, the distance shall be 3 meters or 4 meters depending on this. If the turnpad is intended to be used by aeroplanes with a wheelbase of 18 meters, that means the distance between the center of the nose wheel and the main landing gear, if this is less than 18 meters, in that case the clearance between the outer main gear wheel and the pavement should be 3 meters. As you can understand, if this distance increases, the turning radius of the aircraft also increases, thus you need a greater spacing. Now in this case, in the next case, if the wheel span of this aircraft is 18 meters or more, in that case the clearance required would be 4 meters. Now let us look at the slopes on the turnpads. The longitudinal and transverse slopes on the turnpad shall be sufficient to prevent the accumulation of water on the surface, and it should ensure there is rapid drainage of water on the surface. And preferably it should be same as that of the adjacent runway surface. As you can see here, the slope should be same as that of the runway surface here. Now, the strength of the pavement shall be at least equal to that of the adjoining runway surface. Now, we say at least because there is slow moving traffic on the turnpad and there is turns being performed on this pavement. So, strength of this pavement that is required on the turnpad should be at least at a minimum equal to that of the runway or even more, because this surface will be facing higher stress. Further, let us look at the surface of the runway turnpad. Now, as it is quite evident, the turnpad surface should not have irregularities because it may cause damage to the aeroplane using the turnpad. Further, it should be the friction characteristic of this particular surface should be at least equal to that of the adjoining runway. Now let us look at the shoulder for runway turnpad. It shall be provided with the runway shoulder with width as it is necessary to prevent the surface erosion by jet blast of the most demanding aeroplane for which the turnpad is intended, and any possible FOD damage to the aeroplane engine. So basically, these turnpad shoulders should be designed for the most demanding aircraft in order to prevent erosion due to the jet blast and FOD injection into the aeroplane engines. Further, the strength of the runway turnpad shoulder shall be capable to withstand the occasional passage of aeroplane. It is designed to serve without including any structural damage to the aeroplane and to the supporting ground vehicles that may be operating on the shoulder. Basically, we can understand these shoulders should be capable to withstand the occasional passage of the aircraft and the vehicles that will be serving this area. That is all for this short video on physical characteristics where we have understood the dimensions and the characteristics required for runway shoulders, the runway turnpad and the turnpad shoulders. Enjoyed this video by Aviation Avi. This was prepared jointly by Shantanu and myself Anvesha. If you like our work, do not forget to like, share and subscribe because your support is our motivation. Thank you.